We import Flask to create the web application, render_template to serve HTML files, request to handle incoming data, and Jonify to return JSON responses. TF-IDF Vectorizer converts text into numerical vectors so that machine learning models can understand the text data. Logistic regression is used to classify user messages into different intents based on the text features. This initializes the Flask application. These are example user inputs that the bot will learn from. Each sentence represents a possible user intent. These labels correspond to the training sentences, indicating what type of intent each sentence represents. This dictionary maps predicted intents to predefined responses the bot can send back. We create a TF-IDF Vectorizer to transform text data into numerical feature vectors. The vectorizer learns the vocabulary from the training sentences and converts them into vectors the model can work with. We initialize the logistic regression model. The model is trained using the vectorized sentences and their corresponding intent labels. This defines the home route of the web application. This function runs when a user visits the home page. It renders and returns the index.html file to the browser. This route handles post requests sent to /chat when a user sends a message. This function processes the incoming chat request. It extracts the user's message from the JSON request body. The user's message is converted into a TF-IDF vector using the trained vectorizer. The model predicts the intent of the user's message. Based on the predicted intent, the bot selects the appropriate response. If no match is found, it uses a default fallback. The chatbot's response is returned to the frontend in JSON format. This ensures the app runs only when the script is executed directly. This starts the Flask development server with debug mode enabled.